Solving quadratic inequalities in one variable. Solving quadratic inequalities refers to finding all values of the variable that make the inequality true. Let's consider the names of intervals, its symbols, definition, and graph. To solve a quadratic inequality, first rewrite the inequality in standard form, with a quadratic expression on one side and a constant on the other. Second, set the quadratic expression equal to 0 and solve for x to find the x values of the critical points of the graph. Third, test one value from each side of the critical points to determine which side of the graph contains the solution. Fourth, plot the critical points and the test values on the number line and shade the region that represents the solution. 5. Write the solution in interval notation, which is the set of all x values that make the inequality true. Let's have an example solving quadratic inequalities in one variable. Example number 1. We have x squared plus x minus 20 less than 0. Consider set the quadratic expression equal to 0. We have x squared plus x minus 20 equal to 0. Let's factor the equation. Get the factor by factoring the last term of the equation. Negative 20, 5 times negative 4 is equal to negative 20. And positive 5 minus 4 equal to 1. And now we have x plus 5 and x minus 4 equal to 0. Solve for x to find the x values of the critical points of the graph. We have the first value, x is equal to negative 5, and the second value of x is equal to positive 4. Let's make a graph and plot the critical points. We have an interval of negative infinite to negative 5. And another set of interval, positive 4 to positive infinite. And the interval of negative 5 to positive 4. Now, we will write the solution in interval notation, which is the set of all x values that make the inequality true. We have intervals, test numbers, sign of expression, and less than to 0. Less than 0 is referred to our original given less than to 0. Let's write the intervals negative infinite to negative 5. We have another interval of negative 5 to positive 4. And another set of interval positive 4 to positive infinite. And now we need to choose our test numbers between negative 8 to negative 5. We have between negative 5 to positive 4, we have 0. And between positive 4 to positive infinite, we have positive 6. We need to substitute our test numbers to the quadratic equation. We have negative 6 raised to the power of 2 plus negative 6 minus 20 equal to 0. So we have positive 36, negative 6, negative 20, and equal to 10, positive 10. The first sign of expression is positive. Let's try to substitute 0 to the quadratic equation. We have 0 raised to the power of 2 plus 0 minus 20 equals negative 20. So the second sign of expression is negative. And let's substitute the positive 6. So we have 6 raised to the power of 2 plus 6 minus 20 equal to positive 36 plus 6 minus 20. So we have positive 22. The first interval less than 0? No. Second interval less than 0? Yes. Third interval less than 0? No. Therefore, the solution set is equal to negative 5 and 4. Let's have another example. Feel free to pause the video to answer the given problem. We have x squared minus x minus 12 greater than 0. Let's consider x squared minus x minus 12 equal to 0. Let's factor the equation. To factor the equation, let's factor first the last term of the equation, which is negative 12. Negative 4 times 3 is equal to negative 12. Negative 4 plus 3 is equal to negative 1. We have a factor x minus 4 and x plus 3 equal to 0. Now, let's set the quadratic equation equal to 0 and solve for x to find the x values of the critical points of the graph. We have x equals 4, the first value of x, and x minus 3, the second value of x. Now, let's make a graph and plot the critical points on the number line. We have negative 3 and positive 4. We have an interval of negative infinite to negative 3. And interval of positive 4 to positive infinite. We also have an interval of negative 3 to positive 4. Now, we need to write the solution in interval notation, which is the set of all x values that make the inequality true. We have intervals, test numbers, sign of expression greater than 0. Greater than 0 because our original problem is x squared minus x minus 12 greater than 0. So we have to write the intervals. We have negative 8 to negative 3, negative 3 to positive 4, and positive 4 to positive infinite. We will choose test numbers between negative 8 to negative 3. Negative 3 to negative 4 we have 0, and 4 to positive infinite we have 5. Write the quadratic expression and substitute the test numbers. We have negative 4 raised to the power of 2 minus negative 4 minus 12. We have 16 plus 4 negative 12 equal to 6. The first sign number is positive. Let's substitute the 0. We have 0 raised to the power of 2 minus 0 minus 12. So we have negative 12. And substitute positive 5. We have 5 raised to the power of 2 minus 5 minus 12. So we have 25 minus 12 minus 5 equal to 25 minus 17 and positive 8. So we have positive 8 on the sign of expression. Positive greater than 0? Yes. Negative greater than 0? No. Positive greater than 0? Yes. Therefore, the solution set is equal to negative infinite to negative 3 union to positive 4 to positive infinite. Don't forget to determine which side of the graph contains the solution. Thank you for watching, and I hope you learned a lot.